It is 40 minutes past midday here at Rocket Lab's Mission Control Centre in Auckland, New Zealand, where launch operations are well underway in the lead up to our 36th Electron launch. Hello and welcome to our live broadcast for Rocket Like a Hurricane, a dedicated mission for NASA to launch the TROPICS constellation of hurricane monitoring satellites. Today's mission is flying from Pad B at Rocket Lab Launch Complex 1, our private spaceport on the Mahia Peninsula in New Zealand. T0 for Rocket Like a Hurricane is set for 1 p.m. local time. And for our friends at NASA watching in the United States, that translates to 9 in the evening Eastern Time, 6 p.m. Pacific, and a very early 1 a.m. UTC. My name is Muriel Baker.
And I'm Keegan Black, and we are thrilled to be with you for today's mission. Our launch and safety operations teams at the range in Mahia and here in Rocket Lab's Mission Control Centre in Auckland are heading into the final T-minus 18 minutes of the countdown after methodically proceeding with final checks and preparations for Electron, NASA satellites and the launch pad to make sure all systems are healthy and ready for launch.
We have an exciting pair of satellites from NASA on Electron today. The two 3U CubeSats will begin a new constellation in low Earth orbit to monitor tropical cyclones, including hurricanes and typhoons around the world, hence the TROPICS name, which stands for Time-Resolved Observations of Precipitation Structure and Storm Intensity with a constellation of smallsats. Another great NASA acronym. Today's mission is the first of 2 dedicated Electron launches to deploy the constellation.
This first launch has been dubbed by the NASA team as Rocket Like a Hurricane, and in about 2 weeks' time, we'll be following up with a second launch. That mission has been affectionately called Coming to a Storm Near You. Both missions are heading to a 550-kilometre circular altitude above Earth at an inclination of about 30 degrees. This is a unique orbit best reached with a dedicated launch, making Electron the ideal launch vehicle to deploy TROPICS. Here's more from NASA about TROPICS and its importance not just to NASA's Earth science team, but for all of us eager to have more accurate and more timely information on powerful storms when they come our way.
Here's a question. How does a group of satellites, each no more than a foot long, help improve forecasts for tropical storms and hurricanes? Let's take a look. Hurricanes are some of the most powerful and destructive weather events on Earth. The 2020 Atlantic hurricane season was brutal, producing a record-breaking 30 named storms. What's more, 10 of those storms were characterized as rapidly intensifying, some throttling up by 100 miles per hour in under 2 days. Many weather satellites will generally measure a storm only once every few hours, leaving gaps in coverage where a storm may quickly strengthen. To help fill this observation gap, NASA is launching TROPICS, a collection of satellites designed to make a big impact on our understanding of damaging storms. Their mission? To provide near-hourly observations of a storm's precipitation, temperature, and humidity, allowing scientists to better understand what drives a storm's intensification. To achieve this, researchers at MIT's Lincoln Laboratory developed a miniaturized microwave radiometer that's about the size of a cup of coffee. This small instrument will measure storm strength by detecting the thermal radiation naturally emitted by the oxygen and water vapor in the air. As Earth's climate continues to change, cost-effective but powerful satellites like TROPICS will be an important tool to help us better observe developments driving rapid changes in powerful storms, and help forecasters better predict and prepare for the weather ahead.
TROPICS has been a massive team effort to get the satellites from idea to the launch pad, with the science team led by the Lincoln Laboratory at the Massachusetts Institute of Technology, and others including researchers from the NASA Goddard Space Flight Center, the National Oceanic and Atmospheric Administration, or NOAA, and several universities and commercial partners.
Few people have been closer to this mission than Stuart Cook. He is one of the mission managers for the TROPICS program. And we were lucky enough to catch up with Stuart earlier in the week at our production complex. Let's take a look.
My name is Stuart Cook, and I work for NASA Langley Research Center. My job title is I'm the mission manager for the TROPICS project. Think about 4 satellites orbiting the Earth These satellites are looking down at clouds, at storms, at hurricanes, and they're looking to see how they form, how they intensify, or how they get stronger. So with TROPICS, we have 4 CubeSats that are going to be orbiting the Earth. They're about the size of a loaf of bread, so very small compared to your traditional satellites. And the beauty of having 4 of these things orbiting the Earth is that they can revisit a storm every hour, which is very different from how traditional satellites do it. They may come by the same storm once every 10 hours. The data from TROPICS, we're going to feed that to our partners, which are like NOAA, the National Hurricane Center. They take it and it helps them improve their hurricane forecasting and hurricane modeling. So when you think about it from the end users and you look at a TV and you say, hey, a hurricane's coming up the coast of Florida, it says the storm could go this direction, it could go this direction. We have improved models that will have a tighter band of where that storm is going to be. It's giving better forecast information to not only NOAA, but to the viewers. So for the first launch is, we're going to have a launch window of maybe 2 hours. It says it can launch between 1 and 3 p.m. New Zealand time. The second launch, there's a lot of synchronization that has to happen, so it's pretty exciting for a company like Rocket Lab to be able to do that with that kind of precision to help us meet our mission goals. During the launch, I'll be in the Mission Control Center here, so that'll be a new experience. I'll be on console to give the roll call for all systems go for the payloads. We're just so excited to really see it happen now. I can't just contain my excitement because it's just a lot of anticipation leading up to this moment.
We are very much looking forward to delivering those spacecraft to their new home in orbit, launching in just 13 minutes' time. Right now in the countdown, we are at that 13-minute mark and counting as our launch team gets into the final go, no-go poll for today's launch.
Our launch director today is Joseph Carpico. He will run through the list of operators at the range here in Mission Control to check in on whether all systems are go for liftoff. Let's bring up Mission Control audio now to hear the poll get underway.
All operators, this is the LD on mission, proceeding with the go, no-go sequence. Stage.
Stage is go.
Avionics.
Avionics is go.
GNC.
GNC is go.
VCON.
VCON's go.
T1.
T1 is go.
GC.
GC is go.
PLS.
PLS is go.
RSO.
RSO is go.
MET.
MET is go.
MM.
MM is go.
LD sub.
LD sub is go.
The go, no-go sequence is complete. We are now T-minus 11 minutes, 30 seconds and counting. We are go for terminal count at T-minus 10 minutes. From this time, the 3-word hold procedure is in effect.
Great news there from Mission Control. We are go for launch and ready to rocket like a hurricane for today's first TROPICS launch for NASA. You also heard our launch director confirm today's liftoff target, which is set for 1 p.m. local time, or 9 p.m. and 6 p.m. Eastern and Pacific.
Looking back at the launch pad as we count down to liftoff, let's take you through the Electron rocket carrying the TROPICS payload. Electron is a 2-stage-to-orbit liquid-fueled launch vehicle designed specifically for small satellite missions. At the bottom of the first stage is where we have 9 3D-printed Rutherford engines located. A 10th space-optimized Rutherford engine takes us to orbit with our second stage.
The Rutherford engines use liquid oxygen and RP1 kerosene as its propellant and oxidizer, and these are fed into the engine's combustion chamber in a world-first way, using electric pumps powered by batteries. Electron's structure is made of a carbon composite material, a super strong yet very lightweight material that gives our rocket its sleek black look. It's white now because of the cold liquid oxygen in Electron's tanks, which causes moisture to condensate as ice on the outside of the rocket. The TROPICS satellites are mounted to the rocket's kick stage inside Electron's fairing or nose cone.
At around 3 minutes into flight, that fairing will separate into 2 halves, exposing the satellites to space ready for deployment. This mission, though, is a little different to a standard Electron launch after this point, because typically Electron's second stage would take us to an elliptical orbit around Earth, and then the kick stage would complete a final circularization burn with its tiny 3D printed Curie engine. But for TROPICS, the second stage will be used to circularize the orbit, and the kick stage will instead perform an inclination change to place the two TROPICS CubeSats into a precision orbital position.
Avionics LD mission.
LD avionics.
Yes, sir. Please proceed with sequence 56, the avionics terminal check sequence.
Sequence 56 in work. S-band is switched to high power for flight.
Stage LD on mission.
LD stage.
Please proceed with sequence 57.
After today's first pair of TROPICS satellites are deployed, the second set on our next Electron rocket must be launched soon after, so that the constellation is up and running in time for this year's Atlantic hurricane season, beginning in June. So even before we have liftoff today, we know our second rocket will be rolling out to the pad for launch in approximately 2 weeks from now.
The TROPICS launches won't be our fastest launch turnaround to date. That record is just 7 days, which we achieved earlier this year with a mission from LC2 in Virginia that was swiftly followed up days later with a launch from LC1 in New Zealand. But 2 weeks between dedicated smallsat missions is something that just did not exist for smallsats prior to Electron. Part of the reason we can deliver these missions one after the other so quickly is down to our comprehensive parallel test programs to prepare multiple Electrons for the big day. Rocket Lab mission manager Jane McNichol has been across the entire campaign for TROPICS. She has more to share on what's involved in the lead up to launch.
My name is Jane McNichol. I'm a mission manager at Rocket Lab, and I'm the mission manager for the 2 TROPICS missions. So as we know, the number of hurricanes we're experiencing every year is increasing due to climate change. And the intensity of these storms is also increasing. The current technology that we have on orbit to monitor hurricane development may only be able to check in on these storms every couple of hours, but within that time, we might see a storm increase in intensity quite a bit. TROPICS is a constellation of 4 CubeSats that will be able to monitor near hourly these intense tropical storms in terms of precipitation, temperature, and humidity, and collect this data for us. And this data has the potential to save lives and livelihoods. So it very well aligns with Rocket Lab's mission to improve life on Earth by enabling access to space. Before the launch vehicle even makes it to the launch site on launch day, it undergoes months of rigorous testing, starting with small component testing like our avionics, up into large stack testing or hot fire testing of our engines at our test sites, and then a full end-to-end wet dress rehearsal or practice for launch day. And this is all part of making Electron the most reliable small launcher on the market. Once the satellites arrive at the launch site, the satellite team from NASA and MIT Lincoln Laboratories will be inspecting and doing some final checks on the satellites to make sure that they're ready to be installed on the launch vehicle. In parallel with those tests, Rocket Lab is also running additional tests on the launch vehicle, which is fully delivered to the launch site by this time. We'll be doing integrated testing end-to-end of our avionics systems and preparing for the satellites to be integrated onto the kick stage. Then we will encapsulate the spacecraft and integrate the full launch vehicle, stage 1, stage 2, stage 3, and roll out for wet dress rehearsal. A wet dress rehearsal is basically a practice for launch day, where we perform all of the operations like we would on day of launch, including fueling the vehicle. And this gives us extra assurance that everything will go according to plan on launch day. Then we'll review the data from that test and proceed with launch. Everyone has a hand in helping Electron get to the pad for launch day, starting with our design team, into our manufacturing team, as well as our test and LC1 team, all the way to mission control and the engineers there behind me. This is a team of dedicated engineers who have gained their experience over 30 plus launches here at Rocket Lab. So as a mission manager, that means that I get to work closely with our customer, NASA and MIT Lincoln Laboratories. And I am so excited for launch day and being able to tell them that we've successfully deployed their satellites in orbit and see the real work begin there for them, and be able to see the excitement, not just once, but twice, because we've got 2 back-to-back missions coming up. So I can't wait for launch day. I'm really psyched about it.
As we approach T-minus 4 minutes to liftoff, let's take you through the last moments before those 9 Rutherford engines ignite.
At 2 minutes before liftoff, the ground power supply at the launch pad is disabled and Electron switches to internal power. Our launch safety system, the AFTS, will be enabled at the same time, and we can expect to hear both of those calls from our operators in mission control, one after the other. The liquid oxygen supply valves on stages 1 and 2 are closed about 10 seconds later, with another operator expected to confirm on comms that LOX load is complete.
At under a minute to liftoff, the propellant tanks will be at their optimum pressure levels for launch. Ground control will soon afterward confirm the water system at the launch pad is ready to be activated for when the engines on the rocket ignite for launch. This is what will cause the large white cloud of water vapor at liftoff.
At T-minus 10 seconds, the launch director will count down with the mission clock to liftoff. The engines will ignite at T-minus 3 seconds, and the launch pad's hold-down mechanisms will be released. Then Electron will take to the skies for its 36th launch for this TROPICS mission to space. We'll bring up the audio channels from Mission Control now to listen in, and then we'll be back with you after liftoff.
All operators LD on mission. We are go for auto sequence start at T-minus 2 minutes. LD is go for launch.
Vehicle is on internal power. AFTS is green and enabled for flight.
LOX load is complete. System is in recirc. Anti-geysering is disabled.
Stage 1, stage 2, press for flight.
High flow engine purge enabled. Deluge activated.
T-minus 20 seconds and counting. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1.
HVB discharge is nominal.
Electron is soaring through the sky right now after lifting off from Pad B at Launch Complex 1, now on its way to low Earth orbit for NASA and TROPICS. The first launch milestone the rocket will pass through is Max Q, when the forces against Electron are at their peak as the rocket moves quickly through the atmosphere. Mission Control is expected to call that out on the net shortly.
Clear at Max Q.
Great news there with Max Q and onward and upward for Electron. It has only been about a minute since liftoff, and already the rocket is at its speeds of over 2,000 kilometers an hour, a mere fraction of the 27,000 plus kilometers an hour that is orbital velocity, which will reach ahead of payload deployment in the next 30 minutes or so.
Next, though, is the separation of the rocket between stages 1 and 2. For that to happen, we first need the 9 Rutherford engines currently burning hot to shut down, an action called main engine cutoff or MECO. Then a few moments later, stages 1 and 2 will spring apart. We'll hear that called out as stage separation. Then the single space-optimized Rutherford engine on the second stage will light up and carry on with the TROPICS mission. Those milestones should be taking place at around T plus 2.5 minutes.
"15 seconds to MECO.
Entered burnout detect mode.
MECO confirm.
Stage separation successful.
Stage ignition.
Exactly as we expect, there goes MECO, stage separation, and we can now see that the Rutherford engine nozzle is glowing hot on the second stage. The TROPICS satellites remain in good health on the Electron, and soon the rocket's onboard computer will command the fairing to separate and fall away. Now that we're in the vacuum of space, TROPICS doesn't need the protection of the fairing anymore, so we get rid of that dead weight to maximize fuel efficiency on the way to orbit.
Fairing separation successful.
If you're looking at the screen at the right moment just there, you will have seen those 2 nose cone halves falling away as planned with the fairing separation. Electron is performing nominally on its way to orbit with a few minutes between now and our next mission milestone, the battery hot swap for our second stage engine at around 6 minutes, 52 seconds into flight.
Guidance is nominal.
Stage 2 propulsion, still nominal.
Electron and TROPICS are moving at a good pace right now, well over 8,000 kilometers an hour at the T plus 4 minute mark into the mission. The vehicle is currently at 234 kilometers in altitude, with another 300 or 50 so kilometers to go until we reach our 550 kilometer destination.
Getting there is only one part of the journey, though, as TROPICS won't be released immediately at that 550 kilometre first touch. The satellites will remain attached to the rocket's third stage and complete a full loop of Earth before they can be deployed on their home orbit. We'll explain that process in more detail later when we get closer to that point of the mission.
Stage 2 propulsion hold nominal.
A quick check of the dials on our screen tell us that all remains nominal for Electron and TROPICS. The rocket is moving steadily at more than 9,000 kilometres an hour, and we are inching closer to that 550 kilometre mark now that Electron has passed more than 300 kilometres altitude. To keep the mission running smoothly, we'll have another launch milestone coming up soon. It is called the battery hot swap, and it's essential to keeping our Rutherford engine running all the way to the mission's altitude destination. That action is due at around 6 minutes and 52 seconds in flight, so in just another 1 minute or so.
Guidance is nominal, 200 seconds remaining.
What we call the battery hot swap maneuver is a unique action for our Electron rocket. When the first 2 battery packs supplying power to our electropumps on stage 2 are close to being drained, Electron switches to a fresh battery that will ensure the Rutherford engine lasts the distance to orbit. It's a move our rocket has performed countless times before, but it is a move unique to Electron. Battery hot swap is on its way in just a few moments, so we'll bring up the mission control comms again to listen out for the call.
Throttling down.
Hot swap successful.
Battery jettison.
Just as it was planned, the Rutherford has switched to its new power source with the battery hot swap and is continuing nominally with the TROPICS mission. There are a few minutes left in the engine's burn time before the second stage completes its final actions for the mission, shutting down Rutherford and then separating from the third stage.
Yes, has saved. HVB discharge holding nominal.
How beautiful are some of these views from Electron? This nominal Rutherford burn marks our 360th engine in space, inching us closer to our 400th engine milestone, expected on our 40th Electron launch. In fact, one of those engines to fly next will be an engine that we have already launched before. We are taking the next major step in evolving Electron into a reusable rocket by launching a pre-flown Rutherford engine on one of our missions later this year. That engine, which flew on our There and Back Again mission in May 2022, has undergone the same extensive testing and acceptance processes as any newly built engine and has performed flawlessly throughout multiple full mission duration engine tests. We are very excited to see that engine back on the pad soon. But back to TROPICS, and that second stage is performing well and the TROPICS payload is healthy as both continue travelling at speeds of over 19,000 kilometres per hour.
Entered burnout detect mode.
All right, at T plus 8 minutes 56 seconds into this mission for NASA, and we are nearly in orbit. In a few moments, we'll be able to see that red hot engine nozzle there start to turn cold once the engine on stage 2 shuts down.
Mission control will call out these actions. Listen out for SECO confirmed on the nets coming up shortly.
SECO confirm.
There it is from Mission Control, met with a good cheer from our team. SECO and stage separation confirmed. That means our kick stage and TROPICS satellites are now in their phasing orbit of Earth. It's been a perfectly nominal mission so far, but Electron's work isn't quite done yet.
That's right, TROPICS is a bit different to our usual launches. For this mission, the second stage sending the kick stage directly into a circular orbit, rather than the kick stage taking the satellites on its usual elliptical journey around Earth first. Then, once the kick stage passes the equator at what is called the ascending node, the kick stage's Curie engine lights up to change its inclination to end up in TROPICS' desired orbit.
So while we wait for that Curie burn, we'll take a short break on the live stream now and join you then to hear those final confirmations come through from Mission Control. We'll be back soon.
Great to have you back with us for the webcast of our 36th Electron launch, the Rocket Like a Hurricane mission to deliver the first pair of TROPICS satellites to orbit for NASA. We had a great liftoff from the pad at Launch Complex 1 today, where Electron cleared the Mahia Peninsula quickly and made its way northeast and successfully passed through early launch milestones like max Q, main engine cutoff, and separation of the first and second stage. The second stage performed excellently through its launch milestones too, including battery hot swap and second engine cutoff before T plus 10 minutes into the mission. Now we are here with the kick stage carrying the TROPICS satellites to their 550-kilometre altitude destination as we come up to Curie engine burn for that final inclination change.
TROPICS will then be released from their canisterized satellite dispensers, the safety housing made by us for this pair of TROPICS smallsats. We'll have official confirmation of those actions taking place once the kick stage passes over the next ground station off the coast of Portugal. But we'll be following along with the mission in real time with this animation of TROPICS' journey on the kick stage. So we'll bring up the comms channels to listen in on the final few moments of this TROPICS mission. Let's listen in.
Expected nominal Curie ignition.
Word there from Mission Control that the Curie engine is expected to have now ignited. This engine is relightable and it gimbals to orient the kick stage in a very precise manner, allowing our customers pinpoint accuracy for payload deployment. Listening in now for the next call of Curie shutdown ahead of payload deployment.
As Marielle mentioned earlier, we're currently waiting for the Curie engine shutdown, followed by the call for payload deployment for the first pair of TROPICS satellites for NASA. The two 3U CubeSats are each not much bigger than a loaf of bread, and these small but extremely powerful satellites will begin a new constellation in low Earth orbit to monitor tropical cyclones around the world.
TROPICS aims to measure temperature, humidity and precipitation so that we can better understand the evolution and structure of storms, and doing so with a high revisit rate within the hour will be invaluable. Curie engine shutdown is expected at around a few minutes from now, actually, so not long to go. And then a few seconds later, we should hear expected nominal payload deployment from Mission Control. Let's check back in.
Expected nominal Curie shutdown.
There goes Curie engine shutdown, listening in now for payload deployment.
Expected nominal payload deployment.
And there is the call out from Mission Control, expected nominal payload deployment. Congratulations, NASA and the TROPICS team, and welcome to your new home in orbit. When the kick stage passes over the next ground station at Azores, we expect to receive the full telemetry package that confirms everything you've just heard from Mission Control. Look to our social media channels for that update within the hour as we close out this broadcast for our 36th Electron launch.
And we'll be back to do it all over again with NASA for our second launch for the TROPICS mission to place another pair of small sats on orbit for this important constellation. Coming to a storm near you, both literally and figuratively, as our next launch's mission name, is set to fly from Launch Complex 1 in just a couple of weeks' time to help ensure NASA's constellation is up and running in time, ready for this year's hurricane season, set to begin on June 1st.
We're going to end the broadcast now, but you can always keep in touch with us and stay in our orbit by following us on social media to see, hear and learn about what we do here at Rocket Lab. And to follow along NASA's TROPICS mission, you can head to blogs.nasa.gov/small satellites.
Thank you so much for joining us. This is Rocket Lab Mission Control, signing off.